to the class. In today's lecture, I am going to discuss one-way Anova. Okay. So procedure for calculation. In the previous class, we have discussed about the basics of Anova. So now we'll discuss procedure for calculation. First step. First, define the problem for different varieties and different treatments. Okay, like this. So these are varieties x11, x12, x13, so on. So number of items. Okay, sum. So total number of items for each sample. So T1, T2, T3. T1 is what? Sum of x11, x12, x13, so on x1, n1. So this is T1. Squares is T1 square, T2 square, T3 square, like this. Okay. Next step, define the null hypothesis. So null hypothesis is what? H0 equal to mu1 equal to mu2 equal to mu3, so on, equal to mu n. Means what? We assume that our variances are equal. So for given level of significance. Step 3. Calculate the sum of all the contents of n varieties, say T, and their squares, T square, as I said in table. So you have to calculate T and T square. Step 4. Find the correction factor. Correction factor CF is what? T square divided by capital N. Capital N is what? Total number of items. Step 5. Find the sum of squares of individual items. Sum of squares of individual items is given by SSI equal to summation of your each item square minus correction factor. Okay. We have to square each term. Okay. Minus correction factor. Next step is find the sum of squares between the samples. So sum of squares between the sample is given by SSB. It is calculated using summation of this Ti square by Ni. Small ni is nothing but total number of terms minus whatever correction factor we have found, that one. And find the sum of squares within the samples or sum of square due to error by subtraction. So it is SSW is equal to subtraction of these two, SSI minus SSB. Next is calculate degrees of freedom for SSB. Means degrees of freedom for sample space between the samples. The notation is a new here. We have used it as a new one. Then it is given by mu1 equal to C minus 1, where C is the number of columns given or total number of observations. Okay. Now to calculate the degrees of freedom for SSW, samples within the samples. Okay. So it is denoted by nu2. Nu2 is K minus C, where K is total number of items given. Okay. Next step, calculate mean sum squares between the samples and within the samples. So which are respectively denoted by MSC, mean square samples between the sample, mean square within the sample, MSE. They are calculated as, MSE is calculated as SSB divided by mu1, degrees of freedom for SSB. MSE is SSW divided by mu2, that is degrees of freedom for SSW. Step 9, calculate the ratio F. F is equal to MSC divided by MSE. MSE is what? Mean square between the sample. MSE is mean square within the sample. Once you find F ratio, then we need to find the F value using F distribution table. That is F of nu1, nu2. Means what? This is the F distribution table for 0.05 significance level. Okay, these are the values. So we have to take nu1 along horizontally. So horizontally you have to take nu1 value, and whatever nu2 value is there, we have to take it as vertically. Then respective value is given. Suppose your nu1 is 2 and nu2 is 12, then 2 of 12 here 3.89 is your value. Like this we have to observe. So this is called tabulated value of F. So next, after checking this, we have to set up analysis of variance table for one-way Anova. This is the analysis variance table. So source of variation, sum of squares, degrees of freedom, mean sum squares, and F ratio. So source of variation between the samples is SSB and within the samples is SSW. Degrees of freedom for SSB is a new one and SSW is new 2. And mean of sum squares is MSC and MSC. Whatever in previous steps we have calculated, just we have to tabulate in this form. Okay, SSB by new 1, MSC is SSW by new 2. Then F is MSC by MSC by MSE. Okay. Next, if the calculated value of F is less than or equal to table value of F. Understood? So calculated value means whatever value we calculate using the previous procedures. That is, if it is less than your table value, distribution table what I have shown you. If it is less than that value, then we have to accept the hypothesis. Whatever hypothesis, null hypothesis we have defined, that is true. We have to accept that. In case, if the calculated value of F is greater than or equal to table value of F, then we have to reject the hypothesis. Means we have what hypothesis we have assumed, it is not true. Okay. Now we'll check some examples, then you will understand how to apply these steps. Okay. Example 1. There are different kinds of food are tested on 3 group of rats for 5 weeks. The objective is to check the difference in mean weight, that is in grams, of the rats per week. Apply one-way Anova using 0.05 significance level to the following data. Data is given. There are there are 3 types of foods. Okay, food 1, food 2, food 3, and for 5 weeks. Okay, they have tested the for 3 groups of rats. Okay, food 1, food 2, food 3. Now, how to find the significance level? Okay, so to carry ANOVA, that is what? Analysis of variance. According to the procedure, what is the first step? First step, we need to form the table. Okay, before the following table. So table is what? This is the table. So F1, F2, F3, then total and squares. So write down the data. So what are F1 values? F1 values are 8, 8, 12, 19, 8, 6, and 11. Then for F2, it is 4, 5, 4, 6, 9, and 7. And for F3, it's 11, 8, 7, 13, 7, and 9. So these are the available data. Now what is the first step? First step is to sum all these. So add F1 data, F2 and F3. Adding all F1 will give you T1. So when you add all those, you will get 64. When you add F2 values, you will get 35. So then adding F3 values, you will get 55. Then add again this total T1, T2, T3. So total is what? 154. Okay. This is, let us denote by T. T is equal to 154. Then square this. T1 square, 64 whole square. It is 4096. Then T2 square, 1225. Then T3 square, 3025. 55 whole square. Okay. Now, this is the second step, the first step. Now, after this, we need to write down the squares. Okay. Sum of squares. So, For that, to sum of squares, we need this table. The sum of squares are as follows. So what we need to do now? We need to square each data, each value, okay, and then add. So F1, first value we had 8, so square of that is 64, like this. Square each data. 8 is 64, then we had 12, 12 is 144, 12 square, then 19 square, 19 square is 361, then 8 square, again 64, and 6 square, it is 36, next 11 square, so it is 121. So sum of all this, 64, 154, 361 plus 64, 36 plus 121. So when you add this, you will get 790. Similarly, F2 squares. So F2 value we had 4, so it is 16, 5 square, it is 25, then 4 square, it is 16, then 6 square, it is 36, 9 square, it is 81, 7 square, it is 49. So when you add them, you will get 223. Next, F3 column, 11, it is 121, 8, so 64, 7, 49, 13, you get 169, and 7, 49, 9, 81. Okay, we are squaring all the values and adding them. So it is 533. So adding all these will gives us a grand total. 790 plus 223 plus 533 will gives us this value. So this is 1546. Okay. Step 2. So now after this we need to set the null hypothesis. Set the null hypothesis. What is hypothesis? Null hypothesis. We need to do an assumption. Okay. That is H naught equal to mu1. That is H naught is mu1 equal to mu2 equal to mu3. We have 3 sets F1, F2, F3. So their variances are mu1 equal to mu2 equal to mu3. Okay. After defining null hypothesis, what was the next step? In the next step, we need to find the correction factor. So correction factor is what? Correction factor CF. The formula is to find this. It is t square divided by n. So what is our t? T is 154. Capital T is 154. N is total number of items. Total number of items are 18. For each food, we have 6 samples. F1, F2, F3. For each, we have 6. So 6 into 3, 18 total. Okay. So 154 whole square. T square, 154 whole square divided by 18. 154 whole square is 23,716 divided by 18. So it gives us 1317.55. This is correction factor. Therefore, what is next? Total sum of squares is given by SSI is equal to summation of I summation of j xij square minus CF. So it is summation of AI, summation of xij whole square is what? In the previous table, we found that that is 1546 minus correction factor, whatever we get here, that is 1317.55. Therefore, total sum of squares is 228.45. Okay, this is SSI. Now, once you find SSI, that is total sum of the squares, so now we need to find sum of the squares between the samples or treatments. Now we find sum of the squares between the sample. Okay, squares between the samples. We have denoted this by SSB. Okay, that is SSB is equal to summation over I Ti square divided by Ni minus Cf. So what was this? Summation of Ti square by Ni is sum of all T squares. Okay, in the we have what where we have in the first table. Okay, in the first table, last column, last values, T1 square divided by total number of terms. Okay, those are 6. Okay, this is nothing but, if you want, we write it T1 square by N1 plus T2 square by N2 plus T3 square by N3 minus correction factor. Okay. So now T1 square is 4096 divided by 6 plus 1225 by 6 plus 3025 divided by 6 minus correction factor is 1317.55. So when you simplify, so when you divide this, you will get 682.66 plus 204.16 plus 504.166 minus 1317.55. Add all this, we get 1391 minus 1317.55. Therefore, SSB is equal to sum of the squares between the samples is equal to 73.45. This is SSB. So what we have got? We have got SSI and then SSB. Therefore, to find, using these two, we can find sum of squares within the sample. It is denoted by SSW. Sum of squares within the sample, it is given by SSI minus SSB. So SSI is 228.45 minus 73.45. Therefore, SSW is equal to 155. Okay. Now, once we get these SSB and SSW, now our aim is to construct the table. Okay. That is the Anova table. There we need to find the values. The Anova table is as below. So it contains source of variation, degrees of freedom, sum of squares, mean sum of squares, F ratio. So degrees of freedom, sum of squares, you can denote it by SS. Mean sum squares are MSS. Okay. Degrees of freedom by D dot F. So here between treatments and within treatments. Degrees of freedom for between the treatments are what? That is for sum of squares between the treatments are written by SSB, and here it is SSW. Already we have found them. So degrees of freedom between the treatments, we denoted it by new one, that is C minus 1. So C is 3 number of columns or number of treatments given, samples, so 3 minus 1. So it is 2. New 2, K minus C. K is total number of items given. So 18 minus 3. So it is 15. Okay. Now total 18 minus 1, 17 here. Okay. Now SSB, sample squares, sum of squares between the samples is 23.45 and SSW is 155. This already we found here. So now MSS is what? Mean square is, it is MST, mean square. So it is SSB divided by new one. So SSB divided by new one, or we'll write it here. So MST, mean sum square, is equal to, for between the samples, is SSB divided by degrees of freedom for that. So SSB is 73.45 divided by new one is 2. So it is 36.725. Directly we write here 36.725. Then MSE, mean sum square within the samples. So is equal to MSE is sum of squares within the sample divided by its degrees of freedom nu 2. So it is 155 divided by 15. So it is 10.33. So it is equal to 10.33. So here F ratio is 36.725 divided by 10.33. Therefore, F is equal to 3.55. Now, the calculated value for F is the calculated value of F is 3.55. Okay. Now we need to check tabulated value for this is, how to check? As I said, new one is 2 and new 2 is 15. Okay. So second along here, it is for second value, this one, second, then 15th, 15 is here. This is 3.68. The tabulated value of F is 3.68. Therefore, F calculated is less than F tabulated. That is 3.55 is less than 3.68. At for what is that? For which value we found that tabulated value 2,15 at 5% of significance level. Okay. Now, what happened now? F calculated is less than F tabulated value. In this case, what we said, we have to accept the null hypothesis. That is, hence, the null hypothesis is accepted. Is accepted. There is no significance between the three processes. So we can conclude that there is no significance between the three processes. Okay, this is how to solve one-way ANOVA problem. Okay, next video I am going to solve some more examples on one-way ANOVA. Till then, keep practicing. Take care. Thank you.